This is multi-agent system. Okay, so this is the first chapter which we are talking about. That's the intelligent agents. Now, an agent is basically a software program which is autonomous and adaptive in nature, and it has some of its own specific characteristics. Based on the characteristics, they are basically classified as two. One is weak agents and one is strong agents. So weak agents are more like the software agents, and strong agents are those which can perceive the environment via the help of sensors, right, and give the output to the environment via the actuators. Generally speaking, every particular agent perceives the environment and specifies an action to the environment. Now, in case if the sensors are and everything is just associated with software, then it becomes a software agent. Otherwise, it's basically a strong agent. Now, an agent is a hardware, or you can say a more software-based computer system that has these particular properties of, say, autonomy, social ability. So autonomy is basically where the agents will operate without any intervention with the other human beings, and they have some kind of control over the particular action as well as their internal state. So they have the capability of making their own decisions without the intervention of the humans. Social ability is just like the humans interact with each other, right? Similarly, the agents also will be interacting with each other via a particular language, which is basically called as an agent communication language, or ACL. Another property which is there of the agents is that they are reactive, right? So they will perceive the environment and collect the data from the environment and then act upon the environment. So for example, if I have an agent which is specifically based on software, right? So let's say we have a website in which we have an agent which is based. Now in this case, the sensors would be the web page itself, as well as the actuators also would be the display screen itself, through which the communication would be done to the environment. Next is proactiveness. So agents are basically proactive in nature. Uh, that is, they act in response to the environment and they're able to exhibit a goal behavior. So basically, they take the initiative by themselves. Okay, so by taking the initiative, they are symbolized as proactive in nature. So we can think of weak agents as humans, like assistants, or you can say drones that are having limited set of capabilities, and you can give them a task to do, and they can go away and cooperate with the other agents in order to achieve that particular task. They are also capable of taking initiative in a limited way, like a human, right? So the weak notion of agency buys us something, basically a useful computational metaphor and abstraction tool. When I talk about the strong notion of agency, uh, it does have some concepts which are similar to that of the humans. For example, they have their own beliefs, desires, commitments, choice. Okay, so they have this adaptability and learning behavior. Okay, they have rationality. So these are few of the notions which is there for agent to be called as a strong agent. When I build an agent based system, there are basically two kind of issues which is there. One which is the micro issues, the one which is the macro. Micro issues is that we need to design and build an agent that is basically capable of being autonomous, reactive, and proactive in a given time frame. And macro issues are how is it that we get many agents to be interacting with each other so that they can maximize their coherence as well as the coordination. Coming on to agent architectures, now we want to build agents that have the properties of being autonomous, reactive, proactive, right, and also have a social ability wherein they would be talking to each other. So how is it that we do this, and what kind of hardware and software structures would be appropriate in order for me to build such type of architectures, and what are the concerns which need to be considered? So this particular area is called as a agent architecture, wherein we would be considering all these particular factors. Now MAES basically defines an agent architecture as a methodology for building agents, and it specifies how the agents can be further decomposed into a set of component modules and how these particular modules should be interacting with each other. Now the total set of modules as well as the interaction has to provide an answer as to how the sensor data uh, as well as the current internal state of the agent would determine what action it needs to take as well as what would be its future internal state. So an architecture basically encompasses of techniques and algorithms that support this particular methodology. So basically, as we have seen, an agent needs to sense the environment and it needs to perform an action on the environment via the actuators. So when it senses the data via the sensors, how is it that it is going to affect the agent's current internal state, right, as well as its future state? Okay, another professor, Gelbling, considered an agent architecture to be basically a specific collection of hardware and software modules that were typically designated by boxes as with arrows indicating what the flow of data as well as the control flow is going to be among the particular modules. So it was a more abstract view of an architecture uh, as a general methodology for designing a particular module decomposition for a particular set of tasks. Now, most of the rest of this particular presentation will be taken up with a discussion of the various different kinds of architectures which have been developed primarily in AI itself. Now, based on the different set of architectures, we have reasoning agents, right? Now, the classical approach to building agent is to view them as a knowledge-based system and bring all the associated methodologies which is required of a system which needs to do reasoning based on a particular knowledge base. So this particular paradigm is basically known as a symbolic AI, and we define a deliberative agent or an agent architecture to be one that contains an explicitly represented symbolic model of the world. It makes decisions via the help of symbolic reasoning. Now, the idea of a deliberate agent is that to get an agent to realize some theory of agency simply by giving it a particular representation of rules and frames, semantic mix, or whatever symbolic knowledge representation schemes we know, right? Uh, it would not be a good idea to build an agent which would be able to do reasoning. Now, if one aims to build an agent in this particular way, then there are at least two important problems that need to be solved. One is the transduction problem, right? That is of translating the real world into a symbolic description in the time for that description to be useful. Second is representation and reasoning problem. How to symbolically basically represent this particular information about the complex real world entities and processes, and how to get the agents to reason with this particular information in the time for that the result is useful. So whatever said and done, when you are constructing an agent which would be doing the symbolic reasoning, it should be in a particular time frame so that it would be useful to the environment. The former problem has basically led to work on vision, speech understanding and learning, while the latter has led to the work on the knowledge representation, and as well as automate. Now, despite the immense volume that these particular problems have generated, the researchers would accept that neither is anywhere near to being solved. So, this particular problem is yet to be solved as to how symbolic AI can actually help us, you know, build an agent which would be reasoning based on this particular symbolic AI. Now, the under problem lies with the complexity of the symbolic manipulation of algorithms, and most of the search-based symbol manipulation algorithms are intractable. So because of these particular problems, some researchers have looked at alternatives for building agents, and further we would consider efforts that have been made with the symbolic AI community in order to construct the agents. Now there are two agents. One is the initial one is agent 0, and then Plaka, which is a modification of agent 0. Now much of the interest in agents from the AI community has arisen from the particular agent oriented programming language, AOP, which is basically a new paradigm that is based on the societal view of computation. Now, AOP basically embodies the strong notion of the agency, and the key idea is that AOP is uh, directly programming agents in terms of what their belief, commitments, intentions, choices are. Now, the motivation behind such a particular proposal is that as we humans will use the abstraction mechanism for representing the properties of complex system, in the same way we use the intentional stance to describe humans. It might be useful to use the intentional stance also to program for the machines. Now, it has been suggested by one of the persons, let's show him, that a complete agent-oriented programming system will have basically three components. One, a logic for specifying agents as well as describing what their mental state is, an interpreted programming language for programming agents, and an agentification process for converting neutral applications into agents. Like for example, when we have a database and we are converting such particular applications into agents, then that particular process is called as agentification. The results only reported on first two components. So the relationship between logic as well as programming language is basically the semantics, right? And we will skip over the logic and consider first the AOP language, agent 0. Now agent 0 is implemented as an extension of Lisp, and each agent in your agent 0 has four components. One is a set of capabilities that the agent can do, a set of initial beliefs, initial commitments, and a set of commitment rules. Now the key components which determines how the agent will act is called as the commitment rule set. Now each particular commitment rule contains a message, condition, what is the mental condition, as well as what the action is to perform. So on each agent cycle, the message condition is basically matched against the message that the agent has received. So if there is an agent and he receives a particular message, the first thing which is done is the message which has received is being compared with this message condition which has already been framed under the commitment rule. Now the mental condition is matched against whatever is the belief of the agent, right? And if the rule fires, then the agent becomes committed to do that particular action. So, so if there is a matching which happens between whatever its belief is and whatever its mental condition is, then in that case, the particular commitment rule will act, right? And an action would be initiated. So action may be of two kinds. One is the private and one is the communicative. So communicative is when there is just sending of messages, and private is when it corresponds to executing a particular subroutine internally. Now messages can be of three types. One is can be a request message. One is that so if in case there is a request message, it is basically to commit to a particular action. When there is an unrequest, it's basically to refrain from any particular action. Next is informs, which basically is passing on an information. So as you can see over here in this particular diagram, right? Uh, so initially we have this is what is the state of the agent, and then later there is a a comparison which is done between whatever its beliefs are as well as whatever is the matching rule. Similarly, we have the other points which is there. So if I consider a commitment rule to be framed as with the help of a programming language, right? So here if I say agent basically requests a particular, so a particular time needs to be defined for an action to take place, right? So we need to give that as the message. Now we say that uh, it is a friend agent and can do a particular action, right? So let's just see the explanation of this particular commitment rule. So this rule may be paraphrased as follows. So if I receive a message from the agent which requests me to do action at a time and I believe that the agent is currently a friend, I can do the particular action at the time and I am not committed to doing any particular action since I have already committed myself to doing a particular action at a particular time. Okay. Now this particular example gives a flavor of how the Agent Zero programs are, and this provides support for multi-agents to cooperate and communicate as well as provide the basic provision for debugging. It is however a prototype that was designed to illustrate some of the principles rather than the production language. A more refined implementation was that of Plaka. Plaka is basically planning communicating agents language, which was intended to address some of the drawbacks which were there in Agent Zero, the inability of the agents to plan as well as to communicate requests for actions via high-level goals. The agents in Plaka are basically programmed in much the same way as Agent Zero in terms of the mental change rules. So we can see there is a difference in the mental change rule. Right? So we have that suppose there's an agent which needs to Xerox some particular content, right, and need to do a particular process. So it can achieve that as long as it has its belief, okay, and based on its belief, it will be adopting the particular change, and then accordingly, it will be the agent would be informed that it will be doing the particular activity at a particular time. Now, if someone asks you to Xerox something, you can and you don't believe that there are VIPs that are supposed to be shelving books, then you adopt the intention to Xerox it at 5 p.m. So if you don't have any bookings and you do not have any particular job, right, you can obviously intend to do it, although there may be a belief system which is already present which says that okay, there's nothing like this which is there, like uh, we have the intention of Xeroxing it at 5 p.m. Okay, but if we if we are not having any particular job, then in that case we can adopt the intention to basically Xerox it at a different time, and then correspondingly this particular intention is being updated and then informed uh, that this the intention of the agent is changed and the corresponding task would be done at a particular time.